Hi, welcome back to the session. Welcome all of you back to the session. So we have completed the JDBC API and how to connect with the database. We have seen the retrieval. I tried to actually upload the demos, but the problem is it takes a lot of time and then it disconnects. So I would request all of you, if possible, you can share your email ID. I will again try and zip it and send, because as it is an executable file, we need mail phone support, but still I'll try. And I'll upload all the demonstrations we have done. I hope all of us are back. Just would like to know that if you have any doubt in the last session, welcome all of you. If there is any doubt which you have faced, if you want me to explain any portion, just hold on for a second. I will try to send. Firstly, I'll try and send in the cloud group. In case if it is not available, at least I will send the TXTs. Just 1 second. I know that. Just hold on. You have to again type it, or better, you take down my email ID and you send in your mail IDs there so that I can get it. My email ID is, I'm typing it down, just you can have a look at it. Just have a that the email ID. Yes. Okay. So I hope you are okay. All of you all are okay with the demonstrations without. Alright, so let us now carry on with the next part, that is persistence API, Java persistence API, which we'll see today. Just taking you to the slide where from which part we will actually start off. We have already seen how to make database connectivity. It was a traditional approach, and how we can use JNDIs. Okay, and what are the different ways by which my pool will get created and data source will be accessible, and how can we fetch the data out from the data source. All of these we have seen. Now this is how a graphical representation of how a pool is created, and like only the available objects are forwarded for new connections. Okay, and if the object is idle for a specific duration of time, it will be removed. And here we go with the next part. Hold on for a second, we'll continue with the persistent API, right? So from this point we will actually continue with the persistent API. Object relational mapping software. Firstly, we will have to understand what is object relational mapping and why is it required, and how do we implement object relational mapping. Alright. Second of all, like in object relational mapping, do we have any special software to do that? Okay. And what are those? How do we do it? Okay. How do we connect to the database and what benefits do we reap from that? All of these we will see, and then we will move into the API structure of Java persistence API, and we will continue with some demonstrations to finish the chapters, right? So firstly I will explain you. I hope all of us are logged in. Let us move to the document camera for please have a look at the documents camera where we will see ORM is also known as object relational mapping. Now, any organization would like to implement their database management system in an RDBMS in recent times. Okay. Now RDBMS happens to be the relational database management system where the data is kept in a tabular format, right? So what we can tell our students is, like, we have to ensure that my program or application can seamlessly interact with the database, with the RDBMS database, and for that we should write minimal codes for doing the connectivity. Second of all, we should go for writing writing modular codes so that each module is independent of the other, right? Now what it says is, just hold on for a second. What it says is that application which is based on, say, JNDI is handling the connection pooling, but still we have to write some lengthy lines of codes, right? Now there can be situation where an organization has to, let's say, use data from more than one table. So in the database I might go for implementing a join and then connect all the data. I might fetch the data from a single table. Alright. So if we are combining tables or we are joining tables and making it into a master table and fetching the data, the lines of code that I normally have to write for fetching a single data will be much more difficult in case of combining all the data from the different tables. Again, let me just put it this, say an application which has to fetch, let's say, data from the database table. There is only one table, right? Let's say with 3 columns. Okay. Now for fetching these data, I will have to write maybe say some 10 lines of instructions in my application in the data layer part. But if assume that I have to join, let's say, another table of again 3 columns, don't you think that it will be difficult? Maybe I will have to write some more number of lines, maybe some say 5 more lines I have to write extra. So with the growing volume of data, the number of lines are also going to become complex. It will be again difficult for me to go for combining these lines, combining the tables, and then adding up the lines, extra lines required, and then create the entire data layer. So it will become difficult and lengthy also and complex also. Now if, like I was telling you, say when I am fetching only data from a particular table, might be I have to go for creating one class. Okay. But if I am fetching data from say multiple tables, then I might have to go for creating another class. Let's say the same data, employee and say departments, both will be combined. So for this relationship between two, I have to go for maybe creating the second class, right? So for every possible relation, I have to create different classes and I can say objects in order to hold the data. So which is again becoming a bit troubling, a bit problematic. So in order to write efficient code which can easily help me achieve the insert, update, delete operation on the database, we can switch to some other facilities. We can switch to some other features, right? Now one such thing is object relational mapping. This feature actually is embedded in recent softwares like recent providers like say Hibernate, Made in Java, where we may find that such kind of object relational mapping can be done. Now the API actually which backs it up or which provides us the entire framework for implementing such kind of ORM techniques is known as Java Persistence API, which will help us what should I say, help us connect to the tables, and using ORM feature it will help us achieve the insert, update, delete operation in an efficient way. Now when we are talking about Java Persistence API, the thing is that we might confuse that is it equal to a software like is it equal to a particular software, okay, or a set of libraries. Yes, Java Persistence API has a specification. It is not a software though, it is a specification which says that how the persistence entity, how the database or the storage system will be managed. Okay, how data will be managed in the database, right? Using certain predefined classes, maybe annotations classes, say annotations, interfaces, and so on and so forth, etc. Okay. Now, like we are discussing that object relational mapping deals with objects, and it is one of the easiest way to actually implement the insert, update operations, delete operations in the in an object oriented programming language. So based on object oriented programming language concepts only, they have created this feature. Like what happens exactly in ORM? why is it called object relational mapping? Let us assume that in a database we have a table as, say, customers. Now customers table will have some columns such as ID, name, and say order. So these are the few columns which are available in the customer table. Now just to represent this, I might go for using a class, like a model class which we have created. Say here also we will write customers, but maybe according to me the order of the columns, maybe the structure of the class can slightly differ. Maybe the sequence of the columns can be little bit different. Like instead of ID, name and order, it can be, let's say, we can say order, say name and the respective ID of the customer. Our sequence can be this way. Okay. So it is not necessarily the structure of the class will always match with the database table structure. But in ORM, our motive is this, that we should create such kind of a class which will have a structure mapped equally with the table. So this structure of the customer class will be mapping with ID, say name and say order. Okay, so these three things are mapped in the same fashion, right, like the way in the table it is mapped. So what happens is, in future if we have to represent the entire row of a table, we can expect that one object of a class, one object of a customer class can represent the data of one row in the table. And programmatically managing directly interactions with the table is not easy. So interactions with the object is much more easier. Getting my point? Right? So what we can do is, this is something which we have actually which we will just see in the object relational mapping. Okay, so we don't have to first of all write much code. It is less number of codes that we are writing. Second is that the entire structure of the table is actually based on the object of the particular application, the main objects of the application. Now similarly I can take it vice versa. The entire application actually is modeled on the basis of the table structure, right, where each column to column mappings, column to variable mappings have been done, and at the same time it can easily fit into any kind of database scheme, right, with it very less time. Alright, so these are certain benefits of ORM, and now we can just have a look at this. Say for instance, I have an entire application which has, let's say, which has got certain major, data handling classes, like say employee class is there, plus there will be a class called say departments. These classes, if we group together, can be represented in the same entity as in form of two different tables, employee tables and say departments table. Okay. Now this is known as one-to-one mapping of objects to relational table. This is known as one-to-one mapping of objects to tables, relational tables. Okay. Right. So this is what we can achieve with the help of ORM. Now let's say I was telling you that we have a collection of classes, interfaces which can help us achieve this. This is known as the Java Persistence API. Okay. This API actually helps us to establish all the needful things, to establish all the configuration details, starting from, let's say, the classes, starting from all the annotations that we will apply, all the packages which are needed in order to implement ORM will be provided by the Java Persistence API. Now, how it helps us? It breaks the entire problem. Let's say if handling data and managing the entire database system using the application is the concern, then we can break that entire problem into different modules or different parts, right? It will break the entire data handling problem into parts. The data handling problem in parts. Right? Now each part is given some responsibilities. Like let us discuss the different parts which are required. Okay. Now number one, we require an entity class. Okay. Number two, we require a mapping between the class fields or class variables fields and class fields and the table, you can say table columns, right? Third is a mapping must be the details of mapping, rather I should say details about the object to table mapping must be specified somewhere. Okay, so this the details between the table mapping and the, let's say, mapping with the objects must be specified. Plus apart from this, it should specify which JNDI is to be used. Which JNDI is to be used. Alright, that has to be specified. So again, let us just have a look at this. So first of all, there will be one-to-one mapping between objects to table. Java Persistence API will provide us all of this, all the packages and all the requisites to which will help us achieve this thing. Now apart from this, they have specified that how Java API or in which approach it will handle the overall data management system. The overall process will be taken care in if the JPA will break it in parts, right? How it is breaking things in parts? Number one, it will provide us with a class which we will call as an entity class. Now second is mapping. When we are talking about mapping, the class fields and table columns would be mapped. Mapped means there will be some linkage between the fields of the class and the table columns, right? Third is details about the object to table mapping. Object to table mapping means, say, a particular class must if we will create in our application, must have a respective table available in the database, or you can take it vice versa. If in the database we have made a table, we are actually going to model a class based on that. That will help us identify that what are the major objects of my class that will act as the entity, of the entire application. Okay. Now details about the object to table mapping or one-to-one mapping will be specified. Now which JNDI name will be used to connect to the database. Okay, which JNDI name is going to be used to connect to the database, that is what we will see. And at the same time it says that it will provide number 4, it will provide us with the naming service of JNDI. Like we said that JNDI supports connection pooling, so it will have some names published, say name A, B and so on. Now A is actually mapping to which data source? Data source consists of connection info, so it is mapping to which data source, that is told here. And at the same time it is going to tell us that this data source will be mapping further to which connection pool, right? So it tells us that which connection pool will be used. Now which data source is going to be connected to access the connection pool, and what are the names or the reference names available so that we can just directly connect. So the entire process is managed by the JNDI naming service. So it in fact, JPA in fact tells us that how JNDI will be mapped with the data source, or what are the naming, what are the names available in the naming service. Okay, which will help us to do the mapping, right? So in all the specifications will be given with the help of JPI. Now number 5 is a data source that is connected to a connection pool, that is what we have specified, a connection pool that is connected to the database. So here data source mapped to DB, that is data source mapped to connection pool, and number 6, connection pool will be mapped to the DB, and number 7, the table actual database along with the necessary tables and schema to support the application. So now this database is the one which will have the tables available to help the connection, to help the implementation of ORN, right? Now coming to each one of these, one after the other. Firstly, we have seen that there is something called as an entity class. Now in an entity class, what do we get? In an entity class, we will have the same structure. Let's say if this is an employee class, we will get the same structure in case of the table columns. Say I have an ID field, right, and a name field and a city field, right? So these fields firstly have to be non-public, which is mandatory. These all fields must be non-public. It can be private, it can be protected, or it can be package friendly, right? But internal to a specific package, but it cannot be public. That is the first criteria to make an entity class. Second of all, an entity class must be a class which should not be declared as a final class. Now what is the concept of final class? That we cannot overwrite it, we cannot make changes in a final class, right? You cannot override, extend it. So over here, in case of entity class, we have to have non-final class, which is criteria number 1. We have to have non-public methods, and non-public fields. Fields means variables. We are supposed to have one interface implemented, which is called as serializable, which is a marker interface. We already discussed that. Number 4, we will also have an annotation specifying that this is an entity class. See, creating a class will not only going to say that this is an annotation, this is an entity class, but if we will mention an annotation, a specific declaration is given on top of that class, during the compile time, maybe the class will be compiled accordingly, right? Say for example, the class employee is going to be treated as an entity class. So what is the proof that this class is an entity class? There can be other classes also which are non-final, maybe fields are non-public, and it is implementing serializable. But this does not inform the compiler in any way that this is going to be an entity class. So what we can do is we can specify, we can get some annotations from a particular package called as Java X dot persistence tense dot entity annotation. This will actually help us create an annotation called as entity, which can be applied in the class, which can be applied on top of the class name, so that my class is handled accordingly during the compile time as an entity. Now you will get to see that why in the compile time a special attention is required in this employee class, right? Why the need of annotation is given. Okay. Now we can also declare some, because the fields will be private, okay, or non-public. So we can declare some public methods to create getters, get method and set method. Okay. The annotation which is there will be treated as @ let's say let us assume the annotation which are there will be helping us declare IDs or the primary keys. Like in a table, the entire structure will be mapped but in form of an object. So in tables normally we find primary keys. So the ID ID annotation will define that any column is a primary key or not, right? Or any field is a rather column is not going to be mentioned out here. It should be field. So any particular field or variable within the class is mapped to a primary key column or not, right? And which is needed. This you have to declare. Now there will be last and most importantly, this is number 6, and last and most importantly there will be a no argument constructor to be created. Now no argument constructor means the constructor will be just a normal constructor with no parameters mentioned in it. Getting my point? Now one most important thing that I would like to discuss is that in this class we are supposed to create a variable which is known as private static final long, or int, you can also give int, not a problem. Say serial version UID, okay, which is going to have a value. This value should be a unique value. We may provide this while creating the class, or the Java persistence API can do it for us. Okay. So in our class, another thing that we should remember is we have to declare in the entity class, we have to declare a static final long private variable, that is serial version UID. This variable is going to hold a unique value which will provide us the detail about the version of the class. Why this is needed? Let me tell you. When you are creating objects, let's say from a class, say class A, and you are serializing the object. Say you are serializing the object. If anything changes down the line in the class structure, and let's say while you are fetching back the serialized data, when you are fetching it back into a normal variable, okay, into normal classes object, then in between if anything changes over here, then it will not map. It will throw an exception stating that the contents of the class is not mapping, right? Again, let me tell you over here that say you have an object, right, of a particular class. Let's say the class structure is telling that there are A, B and C variables, and you have serialized this object, okay? You have converted the object into a particular form, right? Now later on you want to read the serialized data, so you have to again fetch it back. That means you have to again go for deserialization. Deserialization is something which you will go for, okay? Now while deserialization, it will try to check what is the structure of the class and what is the content you have got. Now if it finds that there is a mismatch, instead of ABC there is say ABCD has been added, then the data that you are fetching out will never be adjustable in any class A variables, in any class A objects. So that is why we are going to get exception. And therefore if we mention a version ID, that version ID equals to say 1, then we will have a tracking that the object that we saved is of version 1 type. Now when we are deserializing, we will have to check whether the same version is there or not. If the same version of the class is still there, and if the same version of the object is still there, okay, while deserializing, they will be able to easily find out that the class has not undergone any change. And if the class will be changing, if any new element will be added in the class, then definitely the version has to be also updated. So while deserializing, they will check that okay, the version has become 2, and deserializing an object which has an version ID as 1 will not be a good solution, will never happen itself. Am I clear with this? So that is the reason why we have to provide serial version UID while serialization, and while deserialization we have to go for again checking that serialized ID value, whether the two versions are matching or not. Are we clear with this? Till this much, is it clear to all of you? What is so what did we discuss? Again, let's have a quick recap. We discussed about what is persistence API. We discussed about how a persistence API can split the entire data handling part into smaller, you can say, responsibilities, like creating a class and then defining few things inside the class can make my entire class act as an entity in object format, which has an equal mapping in the database as in form of a database table, right? So that's what we have seen so far. Are we clear? And this is one-to-one mapping is known as object relation mapping. Is it clear? Are we clear on this? If you have any doubt, please let me know. Let me know now. Is it clear to all of you? Srijita, Swati, Madhumita, Juma, all of you are through with this? Are you through with this? Type your queries if you have any. If you have understood, at least type so that I can move ahead. Is it clear, everyone? So can you just tell us that what all things we are supposed to put in our entity class? So starting from point 1. Please write, everyone. Type what all are needed in an entity class. What are the points that we should remember while creating an entity class? What are the please answer quickly, fast. Let me.
Hello.
Hi. Can you just name, what's your name? First you tell me.
Ma'am, this is Juma from NIT Galia.
Acha.
Ma'am, am I audible?
Yes, absolutely audible. Can you just name what are the points that we have discussed for creating an entity class?
Yes, ma'am. We mentioned that for creating an entity class, we need mapping class fields and table columns from the database. Details about the objects to table mapping must be specified. Plus, it must specify the JNDI which is to be used, and must specify the JNDI name to connect to the database. Must provide naming service of JNDI.
Yes.
And data source maps to the connection pool. So that connection pool name I need, to which the database will establish the connection with. And this is how ORM, which is object relational mapping, is established or implemented with the database. Then we must take into account that there should not be any, non-final classes, non-public fields, serializable, annotation, all these things to be taken into account of. And annotation will help us create or declare a primary key relating to the table.
Yes.
And there should be no constructor parameter.
Yes.
And when we are sending the request through an object, we must serialize it as in the format, and the version and everything should be taken in account of. And if there is any change, then it will not map with the serialized version. So
Yes, yes.
so it will I mean not allow us to deserialize. So both in serialize and deserialize, both I mean the sequence or that serialization must match.
Absolutely correct. Absolutely correct. So this is what are the things that we will follow in the entity class. This is one particular requirement of persistence API. Okay. Thank you. Thank you. Very
Yes.
Yes. Madhumita, you are also right that we are supposed to create a non-final class, right? So let us again move on. Now, in the next, like all of the points are actually correctly said by Chuma, and now we will see that how the entity class is to be created, and besides creating entity class, Srijita, why you are missing? I have explained this hibernate and what. So where were you? I connected to you. I could not get it. I mean, I could not get any answer from you. You are missing. Hibernate is you can say it helps us to provide the ORM connection with the database, but according to according to Java Persistence API, we get different providers to connect to the database and do the database handling tasks. So this is done with the help of Hibernate. All right. Okay. So the thing is that here they are saying that in entity framework we have been given with few things which are as follows. So here we will discuss about few things about the JPA. Now one is the persistence unit. Another is the entity manager. These are all very important. Third is the persistence context, and fourth is the persistence identity. Now persistence persistence unit is the first one. It means that in this particular you can say feature, we are going to get one XML file which will define all the details that we have discussed so far, like the JNDI, the pool, the JNDI naming service, and the lookup name, which will actually help us reference the data source. The entire detail will be given in the XML, right? And remember, there has to be only one data source which can be mapped with the overall collection of entities. There will be one XML file provided and some collection of classes, interfaces, etc., acting as a unit. Okay. Now each unit of classes which are participating in ORM will be connected to a particular database, that is the data source. Alright. Okay, only one data source should be there. Second is entity manager. In case of entity manager, what happens? They tell us that we have to access. They tell us that we have to access the entity manager, and which is a service object, I can say. This service object will be capable of managing the overall unit of classes which will take part in the transactions. Like for example, I have to insert data. Now I know better that what all collection of classes are available. Okay, what we have to use in order to which particular class or what configurations we have to use to which database we have to connect. All these are known with the help of the XML file, and my service object will simply follow the XML file, and it has been given with some methods like create, update and delete, etc. operations. These methods are given. These are not the names of the methods, but these are the different types of methods which are available in the service object. So if I use the service object, I can do all this stuff, and based on the XML and other details provided, classes provided, I can execute the transaction. Right? Now when I'm talking about the persistence context, now the persistence context is a working form of the collection of classes which take part in the Java persistence API. Like for example, I have a collection of classes which are participating in such kind of operation. So the classes are physically available in some maybe jar file in the persistence unit, or maybe EAR files in the persistence unit, or maybe in some WAR files in form of library. We will get a collection of classes, right, which are participating in this transaction, and service object will make use of those collection of classes, and then it will operate some task in the database, right? But what would be called when the classes will actually be in the running mode, what are they going to be called altogether? They will be called as a persistence context. Now this persistence context will make hold of, rather it should get hold of the service object, and it should implement all the possible things, right? So persistence context is the working of the unit. It's the working form of the unit during the runtime. And remember, the kind of exceptions that we get, all are runtime exceptions that we may get while doing such transactions. And persistence identity. Persistence identity is the unique identity given to every entity instance. When I'm talking about entity, basically I'm talking about the class that takes part in the transaction, database transaction. Now a class instance is object. Now every object should have a unique ID. Okay. When I'm talking about unique ID, this does not mean the unique ID means object's name, uniqueness of the meaning of the object. It's not that. It is the unique ID value which should belong to a particular object. Now if I create another object, it denotes maybe another row in the database. So it should also have a unique identification which is going to be mapped in the database in form of two separate rows. Getting my point? So this is what they are saying. Are we clear? Now when all of these are given to us, we can just have a look at what are the things provided to implement persistence unit. What are the things provided to get an entity manager? What are the things that we will have to implement the persistence context and persistence identity is what. So just in a short discussion we will see this. We will have a look at the persistence unit. The persistence unit will comprise of an XML file called persistence.xml. This is the file where all the configuration information will be given. Plus it will also have a jar or a WAR file or an EAR file with all the classes which will be treated as an entity class. Okay, these files will comprise of all the entity classes available which will take part in the transaction process, and which altogether we are calling as a persistence unit. This is number one. Number two is we have been given with the thing called entity manager. Now entity manager is the one which actually consists of the service that can control. It is the service object which can control the entity classes to do the CRUD operations. What are CRUD operations? CRUD means create, read means fetch the data, update means update the data, and delete means deletion of data. So entity manager will help us control the CRUD operations on the entity classes, right, with the help of the entity classes. So a persistence unit is limited to a single data source. That is another important thing. Now we will have a collection of classes, and every persistence unit should have a unique database, single database associated with it. There can be multiple such persistence unit available, but every one unit should have one specification minimum about a database to which or to whom it would connect and do all the transactions. Now apart from this, we discussed about the persistence context. Persistence context basically comprises of the service object. This is the entity manager. I'm just writing EM. So entity manager will actually be a part of persistence context. Persistence context will have entity manager. Now each runnable environment of those persistence unit will last as long as the transactions are there, as transactions are available. Okay. Now several persistence contexts using the same persistence entity can be active at the same time, but it would last only as long as the connections will be made to the database. Alright. And finally, in the entity manager, what kind of functions do we get for handling the CRUD operations? We get functions like create query, merge, remove, and persist. Create query stands for writing queries to do select kind of operations. Merge stands for merging the updates, like updating the ORM object, which will equally update the tables, the rows of the tables. Similarly, if I will remove something, it will remove things from the database. If I persist, if I want to save something, I will update the object and it will update things inside the database, right? So these are some methods which are provided by the entity manager. Now now entity manager, like I was telling you, is a service object. There is something very important to know, that these objects or such entity manager objects will not be instantiated. When I am talking about instantiation, it means like creating entity manager objects. Say entity manager, I am just writing it in short, EM, let's say, equals to new entity manager. Such kind of object should be created, but this is not done in case of our entity class. Okay, why it is not done? Because like I was telling you, that there is a class and the variable which will be declared, something like this: entity, say persistence entity manager EM. Let's say like this, we will only declare the variable and leave it. Now the variable will be created, or the object, entity manager object will be created, or the memory and all for this will be allocated later on in the later on in the class, right? So over here what they are saying is, there we were last class we were discussing dependency injection, where we have learned this thing only, that we have objects a part of another class, but those objects will not be instantiated, those objects will not be created during the runtime. It will be created later on in the runtime. Okay, like say again I'll just explain this thing. This is very very important. Say I have one object which is going to be created, and there is a part inside the object which is called as EM. Now when I will create this object, automatically this will be also getting created, but this does not happen in case of your entity manager object. What we say is, we create an instance of a class and we say that, see, there is a possibility that I have to create an entity manager, but don't create now, create it, postpone this object creation of entity manager and do it later. So this later on we will do it in the runtime, when need comes. Now this is known as entity injection, right? We are purposely injecting the entity manager object later on when requirement comes in this very class. Are we clear with this? Now here we will see how the entire operation works. In fact, we have support in persistence API. We also have support for implementing transaction, committing a transaction, rolling back a transaction, all of that. So let us now have a look at the demonstration, where we will see how can we create a application to implement JPI, and the thing is that we can use this persistence API in order to fetch the data as well. All we need to know is to start creating the database and GINDI pool, which already we have seen in the earlier today in the morning, right? Just let us have a look at this. So are the concepts all clear to us? So can you all tell me what is CRUD and what is entity manager? What is CRUD and what is entity manager? Can you please type what is the full form of CRUD and entity manager? Madhumita, let me connect to you. Good. Yes, Madhumita, can you explain what is the full form of CRUD? Can you type? You don't have to say, just type. I have already got the answer from Hajra and Garia. Both are right. Absolutely correct. Absolutely correct. Can you just tell me one thing, that what is entity manager? Okay, Garia is also right. The service object which provides the CRUD method, right? Okay. So I suppose all of you have understood till this far. Now we will see the demonstration. I'm yet to get your answer. Just once I get, and then we'll proceed. Okay? Thank you. Now let us have a look at the demonstration. Now all we need to do is just everyone focus. Srijita, you're clear with this? You're through with this? Okay. Okay. Fine. Let us just have a look at the demonstration. So what we have done is we have created an index page firstly in order to create a form and which will accept ID and name, okay, and which has got a submit button which will help us submit the data into the database, right? So this form is going to call the myServlet.do servlet, right? And it is a post kind of it is a get kind of action that we will implement, right? So over here, get kind of a method that will implement while communicating to our action. Now action servlet is this one, myServlet.java, which is going to help me connect to the entity framework. Now entity is this one, entity class is employees, which is there. Now in the entity class, let us just have a look at what all things we have done. We have applied the required annotation, entity annotation, number 1. Number 2, we have implemented the serializable interface, and we have got a no argument constructor also, right? Now this, apart from no argument constructor, there is also another constructor we have created. So this is in addition to the no argument constructor. You have to have the no argument constructor, plus if you want you can also get the other one, okay? And public private static final long serial version UID. You have to give a unique name, right? If you don't give also, they will the persistence API will help us create one unique ID and save it over there. Now there is a column, the ID column is mandatory for all such transactions, right? In any kind of entity class, you have to have an ID column. So private int ID, and this is going to be treated as a primary key. Now the value of the primary key is what kind of values will be generated in the primary key, that is asked. This will be automatically, the type of primary key value will be auto. So it's better you provide this, because they will create an internal column which will have sequential ID values, right? Apart from the ID that we are entering, there are some internal ID values which will be generated automatically and which will help us in doing the tracking of the rows. Fine. Now the annotation column is actually helping us to do a mapping between the class field with the table field, right? And there are, say, some public methods which will do the get and set kind of operations, okay? And other logics will be available. So some hash code overriding and all are there, which we can get automatically. How we will get it automatically? When we will create an entity class, we will have to first of all right click on this package, go to new, and then go to the entity class. So let's say this is our entity class. If we click onto this, it will ask us that what name we are supposed to expect out here, and what would be the data type of the primary key column. Now we will click on to finish, and all of those things will be available. Few things we have to add, like the public no argument constructor, if any other constructors we want to give, or public methods, etc., getters and setters, those we have to add. By default, ID will be always provided. Now the names, now the packages that we have to import. Let's have a look at the packages that we have to import. That is, one is the column, the other one is entity, the other one is generated value, generation type, and ID. Okay, So column, entity, generated value, generation type, and ID. These are the different. You can just simply write javax.persistence.star. Automatically it will be available. Okay. But anyways, you can specify things also. Right. Now let us go to the servlet 1 class. Servlet class. In the servlet class, what happens? We are firstly going to create a variable of entity manager type. So entity manager type variable is EM, and see, we are mentioning something as an annotation is mentioned as persistence context. This means what? That EM is going to be created. The object EM will be created runtime, during the runtime later on. So normally in compilation, if I create an object, if I declare an object and I don't instantiate it, it will throw some kind of exception. It will. May I know who is not able to understand? Who wants me to repeat? Hi. Okay, so the thing is, if you are not able to understand, please type your question. If anything you cannot understand, type your question. So let us continue now. So what it says is, we will have to specify a persistence context annotation, because we are telling that don't create the object right away, just wait, we will have to create the object later on, because it is an entity manager. So through this annotation we will inject an object whenever the need comes, right? Now just because any insert, update, delete is considered as a transaction, we have to specify transaction class and its variable, but again we are not instantiating this object, we are just leaving it like that. The @resource is going to ensure that the object gets created during the runtime later on, right? Now coming to the process request method. In the process request method, we have to see whether assert EM is not equals to null. That means this method, the process request, will only start working, or it will only continue when it will find out that EM has been successfully instantiated by the annotations, right? So because we have already mentioned that it will be only created later on, that's why we will have to again cross check whether the creation is completed or not. Has the enterprise manager been created at the end of the day? So if yes, then only we can continue. Now, so assert is a command which is going to ensure that this is done, and then it will move ahead to the next line. Now here this is like a confirmation. Assert is like confirming that this fact is already this fact is taken place, right? Now ID is the ID value that we are going to fetch from request.get parameter, and string name is a variable which we are going to get from request.get parameter name. So these two are obtained from the first page, that is the index.jsp. And employees emp equals to new employee is the object of the employees class, the object of the entity class I should say, and we are calling the public methods of the entity class to populate the non-public variables. Okay, and then we go ahead with implementing a UTX begin transaction and UTX commit transaction, right? And at the in between the UTX begin and end transaction, we want to save a row inside the database table. Now the specification of which database we are going to connect, what would be the JNDI name. All of these are given in the persistence XML file. So here have a look at this. In the configuration file, under the configuration file you will find something called as persistence.xml. So double click on this and you could see you have to take this persistence.xml file, add it by right clicking and yes. Now here you can directly go to the source and you can specify the details like what would be the name of the persistence unit that will be given. Now the persistence unit will be implementing some kind of a transaction and to which data source it will connect. See, this is the JNDI. We have already created this pool earlier in the morning. So this is the JDBC JNDI name, right, which will be looked for in the naming service, right. Now it will help us find out that what is the database. So the persistence URL for the database is this particular database which we wanted to connect to, and the persistence user is SA, the persistence value is password, password value is password @123, and the drivers that we are going to use in order to make use of the Derby database. So this is the driver. So all these we have specified in the XML, and automatically based on this an entity manager instance will be created and we will be able to do all the operations over there, right. So what happens is, now if we run this application, we will see it is taking a bit of time, but it is just going to get started. So this is our entity framework. Say, let's say I will enter a value as say click on to submit. Will show us a congratulations page stating that my data is saved, right. Now if I want to find out whether my data has actually been saved or not, we will have to click on to the view results link. Again, this link also is implementing JPA API in order to the persistence API in order to fetch the data from the database. So if I click on the view results, we will be able to see that what all details have been inserted in the database, right. So insertion and fetching of data I have shown you. Users can try the same thing, but instead of writing persist method, you have to use merge for updation, and for deletion you have to use delete method, right. Just let me again take you back to the database to show you what is the actual structure and where have we saved it. Let us go to the database available in the services, and we can just go to the admin console once again. admin console once again, and we may also go to JDBC resources, and here you will find that there is something called connection pool already created on as a JDBC my pool. This is our JDBC my pool. This is the JDBC my pool which is already created and to which we had connected using JNDI. And if you will come back to NetBeans services pane again, let me access my pool, which is my database. We will connect to this. We will right click and connect to this and check the table if it is at all been created. We will click on the connect option to do the connection, to make the connection. And we will see that we have actually created a table called employees, and if you will write select star from employees, then we will be able to hold on for a second. I think I'll have to connect to the database, my database. I've connected to somewhere else. Select star from employees. If we will have a look at the output, we will see that these are the details coming up. So these details have been saved and we can read these details out using Entity Manager. Now lastly, just have a look at what changes we have to did in viewing the results. Firstly, again another servlet has been created, and this servlet is linked with the hyperlink. Now here what we are doing, we are specifying here persistence context again, and we are checking that entity manager should be created, but this time we are not going to write assert because we are allowing the object to be empty. Because if the object will remain empty, then only I can fetch the result from the database and populate it, isn't it so? So we will write utx.begin and then we will continue the transaction. This one, in this case, the transaction is going to only fetch the records from the table. So entity manager uses a create query method to select the employee. So see, the select clause is slightly different. Okay, select employee from employees EMP. Now EMP, this is the query, and when we are writing create query dot get result, get result list, then we are actually getting the result or output of the query. So the query is created, but it is executed later, and we are getting the result set back. This result set is going to be saved in the list variable, and list is a list type of variable which is dynamic in nature. So even if you don't have an idea how many rows are there, still list can adjust the total number of rows, and it will we will iterate in the list, and we have created a table using this. Instead of this, my suggestion is, this is just for the sake of simplicity I have done it, but the actual technique should be that you have to create a list like the way I have done and pass this list into the request object as using set attribute. Now from the next JSP page, you can use some JSTL tags, or you can use the code tag library to iterate in the list and print all the values. Now that will be better and easier for you to access the list, and you don't have to write this HTML code. Now here we are doing what? We are after every iteration we are fetching one instance out from the list, and then we are printing all the parts of that object, so which will describe a row. Again when the loop runs, again when the while loop runs, again another object from the list is fetched out, and the object variables are printed one after the other. So like this it keeps happening, and a complete result set gets generated. Are we clear till this much? So just have a look at the code and see what we have done. If you have understood, just let me know. If you've understood, all of you, please let me know. Are we clear with this thing? Click onto the plus icon if you've understood, or type yes if you have at all understood how to do it. Okay. So are we clear with this? Any doubt so far? Anywhere if you haven't understood, please let me know. If you don't have a doubt, then I would presume that you can execute all of these on your own. So anyway, just have a little bit of recap on what I've said. So we are creating the application in order to implement Java Persistence API, and we are implementing Entity Manager service object in order to access certain methods which will help us do insert, update and delete kind of operation. And the creation of Entity Manager is postponed, and it is created later on in the servlet or in the program, because we are using an annotation called persistence context, which will while the runtime will be environment will be created and all the classes will participate, then Entity Manager will be automatically injected inside the class. So this is known as entity injection. And there is a persistence XML file which will provide all the details about the database connectivity, the JNDI data source and the name for lookup, and using the naming service using the name will connect us to the pool. And apart from this, we are using some methods like create query, merge, persist, etc. to save the data into the database, to update the data in the database, etc. Alright. So if you are through with this and you don't have an issue, let me know if you are through with this. If no problem, then we can wind up for today, and tomorrow we will continue with the next part, right?